Presentation is by Trevor Simpson from the School of Optometry, Measuring Ocular Appearance.
There are a variety of things that can go wrong with the surface of your eye or inside of your eye, and often as clinicians we have to look at those things and decide whether that abnormality requires intervention or whether that is even an abnormality. And those things typically are measurements of one sort or the other, and the scales that we will use vary from sort of almost continuous numerical quantitative scales to seeing somebody with something like, all right, I'm not getting a cursor, something like those bumps on their lid up there, to, oh my gosh, what are we going to do? So, no, it's good to, or we have to do something quickly. So those are numerical scales. Sometimes you don't get to do those on living eyes. Sometimes you have to do those on images, and we're involved in, at the Center for Contact Lens Research across the road at the School of Optometry, in large clinical trials. And we have a variety of outcome variables that we have to assess. And sometimes those are, again, you're sitting behind a microscope looking, and sometimes they're not. Ultimately, though, it would be really nice to be able to make those measurements in a completely objective way. Clinically, though, they often are not, and so there are a variety of scales. I'm going to use redness sort of as a case study here. And so I'm going to talk a little bit about some of the redness work. These are a variety of scales that are out there to judge the redness of the white part of your eye. So that would be what we would call the conjunctiva. The top one I'll return to is called the McMoney scale. That one's interesting because the way that McMoney's made that scale is you put a poison in someone's eye. It got really red. And then they photographed it sequentially as the poison and redness went away. This is a scale that was developed by committee, and it's a big mess. And this one was designed by an individual who had a very famous medical artist draw the blood vessels on the surface of the eye, and it sort of was much more controlled. So this one and the top one probably are great. We've done a lot of work with this, but it really doesn't work that well. But the problems are varied. But this is just an example of a problem. This is an experiment where we had a bunch of people judge the bumpiness of lids in a clinical way. Look at the lid. Look at the scale that you have, maybe reference pictures, maybe just words describing the bumpiness of 30 images. These are just 30 images, and these are just different examiners, and it's just a box plot so you can see where the middle is and what the ranges are. And then you have somebody who really sucks at it, and it's no coincidence that it's me. And so you have huge variation between observers, and supposedly we're experts, but who knows what that means. This is another example of how bad it is. This actually is also in clinical redness, and this experiment was done with Paul Feguth in systems design engineering, and we had a bunch of images on the web. People went out and looked at them, judged what the appearance was numerically. Tell us how red this eye is with a scale. You have to grab a slider, adjust the slider, and give a number. The tasks, again, were just a variety of different redness images, and we've normalized it by taking the median value of the scale that was assigned to the median value from all of the images from an individual scale. The point to show is how completely irregular the distribution of the assigned grades are, because clinicians will typically assign grades based on pretty numbers, whatever those pretty numbers are, because that'll depend on the characteristic of the scale. And so we have a real measurement problem. So what do we do? Well, we can go away and use a variety of techniques to characterize the images in an objective way. So here's that top scale that you saw earlier. So this is a redness scale. And here are a couple of physical ways of characterizing the redness. The left-hand scale over there is using chromaticity. So using a device that measures redness, the sort of device that you'd go into Home Depot and say, I want you to match the redness of this thing and give me paint for my basement that's going to be this red. I'm not sure why you'd want a red basement, but that's another story. And then something over here is fractal dimension. In this instance was a box counting fractal dimension way of just characterizing the vessels. So select a region of interest that corresponded approximately to where we measured the chromaticity. So the chromaticity is not really measured with image processing, measured with a photometric device. Take something, aim it in the area that's red. And you can see, though, that we can characterize those images of those eyes in an objective way. And that's what we're aiming for. characterize them in a variety of ways. This is a different experiment done, again with Paul Fegut. Here is our grade of redness judged by clinicians. And there is an aspect of the characteristic of the blood vessels obtained from the images. Again, I think I said I did this with Paul Fegut. So I'm going to stop. We have a variety of ways of characterizing images. I use redness as an example. We use image processing very seriously. Haven't looked at, haven't really discussed why we would do that. We want to do it because we want to do the measurements in an objective way. Why would we want to know how to do that? Well, we can build a machine to do it, but we'd also need to know, we know why people are making judgments about the appearance of these eyes. We can teach them to do it in a more efficient way. We might even be able to optimize a variety of other techniques. So, for example, redness, you can measure using luminance. So an eye which has got a lot of blood on it is a much darker eye. And so you could customize, for example, how images are compressed based on understanding of how clinicians make judgments of redness. Thank you very much.
Just a quick question. Have you tried different image processing techniques and compared them to whatever? What is your standard? I mean, given human judgment, how do you come up with a standard here?
Yeah, it's a real problem. We have a graduate student working in the lab who's working on a thing which we call accuracy. And accuracy clearly is going to be arbitrary because there isn't a gold standard. There are a variety of ways of defining it. You can define it by committee. Not a good way. You can use an ideal observer. That's sort of still arbitrary. And what we're doing is we're going away and measuring a variety of physical characteristics. So chromaticity, I think, really lends itself particularly to defining redness. There are a variety of other things that we look at. We put dyes in eyes, and depending on how the dye is taken up and fluoresces, eyes might be more green if there's something wrong. So that's also photometric. You just have to analyze the sort of physics of what it is that you're doing. The bumpiness of a lid could be texture. It could also be photometric. So we're looking at it, and it's not easy because there are no gold standards.
Thank you. Any questions, comments? Jeff?
Are you familiar with Vladimir Aronofsky? He's in computer science.
Not really, no.
He does a lot of physics-based modeling and simulation of the optics of the eye,
Right.
and color, and sort of.
Yeah.
All right. Be interested in.
Okay. That's good. Yeah.
Any other? Thank you very much.